Hey everyone, in this video I'm going to show you how to build a mold to make 100% recycled plastic skateboard decks. The mold is open source, which means all of the CAD files, the bill of materials and the electronics diagram and all the other information you need is online for you to download for free if you want to build one yourself. The decks are made using an extrusion machine like this one, which is also open source. To find all of this information, check the links in the description to this video. So the whole system can be split into three main parts: the mold itself, the table, and the control box. The mold itself is made from four separate parts: a top and a bottom plate, an edge structure, a support structure, and a set of fasteners to hold it all together. First, you're going to make the top and the bottom plates. You're going to need two CNC cut aluminium blocks, which will form the top and bottom faces of the decks. Some 0.5mm stainless steel washer plates. We ordered 1.5 times the quantity from the 3D model. 10mm laser cut steel sheets. M5 by 10mm dowel pins. M10 by 16mm countersunk bolts, M10 by 30mm countersunk bolts, flat M20 nuts, heat-resistant paint, and some safety stickers. For each of the horizontal plates, you can countersink the M10 holes so that the bolts sit below the surface. You can also countersink the M20 holes on both horizontal plates. For the top plate, you want to countersink the same side as the M10. For the bottom plate, you want to countersink the opposite side. Check the drawing to make sure you countersink the right side. Next, you're going to weld the M20 flat nuts inside the hexagon holes on the horizontal plates. Next, we're going to grind the welds flat. Next, we're going to clean the plates with degreaser and then apply a layer of heat-proof paint. Next, we're going to remove a little bit of paint from the horizontal plates in all of the countersunk holes. This is for electrical grounding. It ensures that there's continuity between the horizontal plates and the aluminium blocks so that both pieces are grounded. Next, we're going to bolt the horizontal plates onto the aluminium pieces. Note that they have an orientation, so you need to measure the nose and the tail and make sure that it lines up with the arrows on the horizontal plate. Between the top horizontal plate and the top aluminium block, there is a stack of stainless steel washer plates. They're stainless steel to prevent them from rusting because we can't paint them. This is because we need a consistent thickness. Adding or removing the plates allows you to calibrate the thickness of the deck. You may need to change the bolt length if you want to adjust the thickness of the deck, but by default it's 30 mm on the top and 16 mm on the bottom. Next, you can insert the dowel pins into the holes in the base plate. These are to mark where you need to drill the truck holes. Finally, stick the safety stickers down each side. Next, we're going to make the edge of the mold. You're going to need the CNC cut aluminium block, some 2mm laser cut sheets, some 10mm laser cut sheets, steel C-beams. We got ours laser cut, but you can also drill them by hand. 1 inch diameter stainless steel round stock. It's the same as many common injection machine barrels, so you may already have some in your workshop. Some plumbing fittings, 2 BSP 3/4 inch weld-on threads, and 1 BSP 3/4 inch swivel adapter. We also laser cut a handle to attach the adapter. This thing is really cool. It allows you to attach the mold to the nozzle of the extruder without having to rotate the entire mold. Some M3 by 10mm socket cap bolts. Some M5 by 10mm socket cap bolts. Some M5 washers. 1 M8 nut. Some M10 by 16mm countersunk bolts. Some M10 by 40mm countersunk bolts. Some heat resistant paint. And some metal paint. We went for military paint because it's strong and durable and available in the same color all over the world. And some safety stickers. There are also some electronics components, but we'll explain that in a different chapter of the video. You'll notice that on one of the end plates there are some extra holes marked for the electronics. Around each of these holes there is a center mark. Mark all of these centers with a center punch and then drill and tap them with an M3 thread.
Masterpieces, sharper thesis. I got this.
Next, we're going to countersink the middle row of holes on the two C-beams and the end plates. Check in the drawings to make sure that you countersink the right side for the end plates.
Definition of L, I reflect. Real hip hop.
You'll notice that one of the C-beams has an extra hexagonal hole. We're going to insert an M8 nut into the hole and weld it in place, and then sand the back surface flat. Next, we're going to weld the threaded inserts into the end plates. They should be slightly longer than the thread of the swivel adapter. This is to make sure that you can tighten it against the aluminium. If they're too long, you can use a lathe or a chop saw to cut them down. Tack, then fully weld the thread in place. It's important to grind the back face flat so that the seal is tight against the aluminium. Once they're welded in place, you can use a tapping tool to make sure that the thread is clean. Next, we're going to apply a layer of heat-proof paint to the inside faces of the C-beams and the end plates that will contact the aluminium block. Before doing so, you need to clean them with degreaser and stick a small round sticker over each of the bolt holes. This is for electrical grounding. It ensures continuity between all of the metal parts. Using a set square and scribe, mark the middle of the C-beam on the top and the bottom face. Next, take the body mounting tabs and tap each of the holes with an M5 thread. Next, we're going to take the end tabs and weld them in place. Take two of the tabs and score a line down the vertical center. The two tabs that you scored are in the middle. Use the score line on the tabs and the C-beams to position them correctly. Weld them in place and then grind the welds flat. Lay your beams around the aluminium block in the position that they will be bolted in place. The C-beam that has the M8 nut lines up with the extra hole in the aluminium block. Bolt the C-beams in place. The end plates need 16mm bolts and the side plates need 40mm bolts. Protect the aluminium using masking tape and cardboard. Tack weld the four corners on the top and the bottom of each part to join the four pieces together. Then fully weld the four corners of the mould. Grind the top and the bottom welds flat. Next, we're going to take the swivel adapter and the flat handle and weld the handle onto the freely rotating part. Screw the swivel adapter into the end plate. Now that the assembly is complete, we're going to apply a layer of heat-resistant paint to the steel frame. First, we need to protect the aluminium. We stuck some sheets of paper over to block the paint. Then, you're going to clean the frame with degreaser. And again, we're going to stick a small round sticker over each of the M5 and M3 bolt holes to protect them from being painted. This is for electrical grounding and ensures that all the panels are connected to the frame. We can also apply a layer of paint to the bodywork panels. Again, clean them with degreaser and place a small round sticker over each of the bolt holes. We just used normal metal paint, it doesn't need to be heat resistant. Next, we're going to make the handles. Take your 1-inch diameter stainless steel rod. If it's not already, cut it to length using a chop saw or a grinder. Using a lathe, drill a 40mm deep hole at each end of the rod. And then tap the hole with an M10 thread. Next, you're going to make the support structure. You're going to need steel C-beams. Again, we got ours laser cut, but you can also drill them by hand. Some heat-resistant paint, and some safety stickers. Take the 4 longer beams. On 2 of them, countersink the holes on the inside, and on 2 of them, countersink the holes on the outside. Next, we're going to weld the 2 support structures. The shorter beams have a specific orientation, and so do the countersinks, so make sure to check the drawing to make sure that you weld everything correctly. To align the middle pieces, you can score a line down the center of each piece. Using a set square and a scribe, score a line on the middle of the long beams and down the center of the shorter beams. This is so that you can align them easily. Tack weld the parts together and check that the holes align with the holes on the top and the bottom plate of the mold. If they do not, adjust them with a hammer or cut them and re-tack them in place. Once you're sure everything is fully aligned, fully weld each section.
This is another one.
So next we're going to grind the welds flat. You need to make sure that the two faces that contact the mold are perfectly flat so that it holds it tight. Once you've grinded the welds, you can clean the metal with degreaser and then apply a layer of heat-proof paint. Finally, you can stick the safety stickers along each side of the frames. The final part of the mold body is the fasteners, which will hold the whole thing together. We went for M20. They're nice and big and strong. We also chose 12.9 grade steel as it's strong and durable, and they're going to be opened and closed many times. You're going to need some M20 by 250mm hex bolts, some extra thick M20 washers, some M20 flange nuts, and some fluorescent paint. Next, we're going to apply a layer of fluorescent paint to the fasteners. This is to make them easy to identify when operating the mold. We taped off the middle section of the bolt, as this will be inside the mold, so it will be exposed to a lot of heat. Next, we're going to make the table. It's split into 3 sections: the base, the legs and the top. We're going to start with the base and work up. You're going to need steel C-beams. Again, we got ours laser cut, but you can also drill them by hand. Some heavy duty caster wheels with brakes. Some M5 by 10mm socket cap bolts. Some M5 washers and some metal paint. So on the 2 foot beams there are some center holes marked. With a center punch and a hammer, mark the center of each of these points. You're going to drill all of these holes with a 4.5mm drill bit. Next, we're going to tap each of these holes with an M5 thread. We're going to mark the center point of the 2 foot beams. So next we're going to weld the base sections together. You can start by welding the 2 longer pieces. You can use 2 of the longer M20 bolts to align the pieces. Next you're going to grind the welds flat. Next we're going to clean the metal with degreaser in preparation for painting. Stick a small round sticker over each of the bolt holes. Now we're ready to paint the base. Once the paint is dry, you can attach the caster wheels. Now the base is done, we can work on the legs. You're going to need some 10mm steel sheets, some steel C-beams, some M10 by 40mm countersunk bolts, some M10 lock nuts, some large M10 washers, some M20 by 80mm hex bolts, some M20 by 250mm hex bolts, some M20 lock nuts, some M20 washers, 4 thin M20 washers, 1 M20 nut, 1 M20 flange nut, 1 M20 dome nut, and 1 M20 bar stud, and an M20 threaded rod, some metal paint, and some fluorescent paint. Start by taking the 2 laser cut C-beams, the laser cut end plates, and the M20 bar stud. So you're going to take the end plates and weld them to the ends of the C-beams. Next, you're going to take the M20 bar stud and position it roughly in the middle of the C-beam that has the hexagonal hole cut inside. Once it's aligned, you can weld it in place. Clean all the beams with degreaser and then apply a layer of metal paint. Next, take the longer pieces to build the legs. You'll notice on some of them there is a small M10 hole. Use a countersink to make sure that the M10 bolt sits below the surface of the piece. Next, we're going to take all of the laser cut parts and apply a layer of metal paint. Remember to degrease all of the pieces before painting. Next, we're going to take the M20 1 meter rod and an M20 nut and weld the nut on the end to make a really long bolt. And grind the head smooth again. Next, take the M20 rod and tape off the thread just below the bolt so that you can apply a layer of fluorescent paint. We're also going to apply a layer of paint to one of the M20 washers and the M20 acorn nut. So next we're going to assemble the legs. We're going to start at the bottom and work up. Make sure to refer to the drawing or the 3D model to make sure that you do it correctly. So we're going to tighten the flange nut just before the end plate so that it can rotate freely, and then weld the nut in place. Finally, tighten the M20 acorn nut to the end of the threaded rod. Now the legs are done, we can finish with the top. You're going to need steel C-beams, heavy-duty compression springs, some M20 by 80mm hex bolts, some M20 washers, some M20 lock nuts, metal paint, some fluorescent paint, and safety stickers. So we're going to start by welding the two C-beams together. Again, you can use two of the longer M20 bolts to align the pieces. Once you finish the welding and the grinding, you can clean the metal with degreaser and apply a layer of metal paint. Next, we're going to bolt the tabletop to the legs. We're also going to apply a layer of fluorescent paint to the springs. Next, we're going to attach the springs to the top of the table. Don't worry about doing them tight because they won't be here for too long. Finally, stick the safety stickers down each side. Next, we're going to install the electronics. You are going to need 2mm laser cut steel sheets, some M5 by 10mm socket cap bolts, some M5 washers, some M5 nuts, some M3 by 10mm socket cap bolts, some metal paint, safety stickers, and the electronics components. There are a lot of electronics components and they're quite specific, so make sure to check the bill of materials to see the full list. We're going to start by building the enclosure. We're going to weld the laser cut parts. And grind all the external welds flat. Tap the 4 bolt holes on the corner with an M5 thread. So we're going to clean the metal with degreaser in preparation for painting. Again, you can stick a small round sticker over each of the bolt holes to protect it from being painted. Do this on the inside and the outside of the front plate. Next, we are going to install the electronics components into the enclosure. This process is very complicated, so follow the schematic to make sure that you do everything correctly.
You can't tell, can't tell, can't tell, you can't tell, can't tell, can't tell.
Attach the power supply cables to the enclosure. Finally, we're going to install the safety stickers on the front cover. Next, we're going to install the electronics into the mould edge. Trim and strip all of the ends of the cartridge heaters. And cut the heat shrink into 30mm pieces. Next, we're going to splice the socket into the thermocouple cable. When you cut it, make sure that there is enough length so that it can reach the hexagonal nut from the end of the C-beam. Once it's cut, trim the ends and then solder the wires in place. Next, we're going to install the cartridge heaters into the holes in the edge of the aluminium. They're 380 volts, so you're going to wire each one between two of the phases. We're going to divide them evenly between the three phases, so 2 groups of 21 and 1 group of 22. You can color code each of the holes with a marker so it's very clear. Start by installing the quick connectors onto the end plate using the M3 bolt. Before installing the cartridge heaters, we can thread the thermocouple into the M8 nut and screw the socket in place. Spread a small blob of high temperature silicone glue on the outward facing end of each cartridge heater to glue it in place. Make sure that the phase that has the extra cartridge heater is not the same phase that powers the components inside the enclosure, such as the fan and the LEDs, as this will draw too much current on the same phase. The cartridge heaters are connected by splicing the wires together and then protecting the joins with heat shrink. Remove the hub for the cartridge heaters and then connect the 3 phase cables plus 1 ground cable and then reinstall the hub. To attach the ground, drill and tap a hole in the bodywork mounting tab closest to the hub, and then using a ground spade, bolt it in place. Next, we're going to install the bodywork panels and the handles. Finally, stick the safety stickers on the end plates and the bodywork panels. So now that we have all of the components that we need, we're going to assemble the mould. Take the bottom support structure and bolt it to the top of the table with the springs in between. Place the bottom plate, the mould edge, and then the top plate on top of the table. Then place your support structure on top. And finally, bolt everything together. Then place the top support structure on top of the mould and use the fasteners to bolt everything together. Finally, we're going to install the electronics box on the base of the table and then plug in the power supplies in the thermocouple. The electronics box has two positions. You can mount it flat or at an angle. So now it's finally time to make a deck. Before each deck, you need to apply a layer of mould release to the inside of the mould. We use silicone oil. Take a cloth, put a bit of oil on it, and then cover each of the inside faces. Once this is done, you can close the mould again, making sure that all the bolts are tight. Now it's time to preheat the extruder and the mould. Plug both of them in. Turn on the control box of the mould and the extruder and set the temperatures. From this point on, it's important to wear the correct PPE. You're going to need overalls, steel toe cap boots, gloves, a mask, glasses, and a face shield. If it's the first time you're extruding a new type or mix of plastic, you can test extrude a little bit to preview the color. Wait for the extruder to heat up and turn on the motor. Load the plastic into the hopper and watch it come out the nozzle. Once you're satisfied with the result, you can attach the mould to the nozzle of the extruder. Roughly line up the entry to the mould with the nozzle of the extruder. You can adjust the height of the mould using the adjustment screw on the table. Use the handle on the swivel adapter to tighten the mould onto the nozzle of the extruder. Now fill the mould by gradually adding plastic into the hopper. You can tell that the mould is full when plastic comes out of the other end. Plug the exit and extrude for a few more minutes to build up pressure. Wait for the mould to cool and then open it up. Check out our next video where we're going to dive much deeper into the process of making decks. projectRPSD is a non-profit organization publishing free open source research about plastic recycling. If you want to support the development of this project, there's a few things you can do to help. You can like us on Facebook and share our posts. You can follow us on Instagram. You can join our mailing list to receive updates about the project. You can make a one-time donation on PayPal, or you can become a monthly supporter on Patreon. All the links to this information is in the description of this video. Spreading the word about our project is a huge help. It opens a lot of doors for us. If you hear about any potential collaborations or opportunities, please let us know. Thanks for watching. See you next time.